Okay, here we are again. Math notes, section 2.2.4, even and odd functions. Even and odd functions. Okay, we're just going to roll right into it. These are probably new terms to you, and it looks confusing at first, but with a little practice, you'll be able to figure it out, okay? So, first thing we're going to look at are even functions. This says when f of negative x equals f of x, the function f is called an even function. So for example, if we have f of x equals x squared, to find f of negative x, we would plug in negative x where there was an x. So that would be negative x squared. And if x squared equals negative x squared, then it is an even function. So that's what they've done down here. Negative x squared, well, negative times a negative gives us a positive, so that's x squared. And then x squared equals x squared. So check. They do equal each other, and this is an even function. Graphically, what does this mean? Graphically, this means that even functions can be reflected over the y-axis onto themselves, reflected over y-axis. They have reflective symmetry on the y-axis, or x equals 0, and I have a little example right here. If we were to imagine folding this function along that dotted line that I just drew, you could see that it would land right on top of itself. And it satisfies the condition there that if we take any x value, a positive x value, and a negative x value, we're going to get the same y value. So if we have x, we go up to our function and we go over to y, which is our f of x, we get this point on the y-axis, or that y value. If we take the negative x, we go up and go over, we get the same point on the y-axis. So f of x and f of negative x equal each other. It has reflective symmetry over the y-axis. That is an even function. The other type of function that we'll look at is called an odd function. Okay? Let's draw a little line there. When f of negative x equals negative f of x, the function f is called an odd function. So in this example, they give you x cubed. Let's find those two values. So f of negative x is going to be negative x cubed, which we could rewrite as negative x times negative x times negative x. So f of negative x is just negative x cubed. And then if we did negative f of x, we're going to take the output value there, x cubed, multiply it by negative 1, and that's also going to give us negative x cubed. So negative x cubed equals negative x cubed, and they both work out. And on this one, it is also useful to think about it in terms of a graph. I actually prefer to think both of these in terms of a graph before I do it algebraically, but you should know how to do both. Okay? Odd functions have rotational symmetry around 0, 0. Rotational symmetry around 0, 0. And I should say, sorry, I left off an important thing there, 180-degree rotational symmetry around 0, 0. That means that if you took this and you spun it 180 degrees, half a circle, it should land back on itself. Now let's try to do this and see if it works out. I'm going to trace this. I'm going to see if I can take my tracing and spin it around that middle and see if it lands on top of itself. 180 degrees. Sure enough, the function landed back on top of itself. So we're spinning it around the origin here of 0, 0. So odd functions have 180-degree rotational symmetry around 0, 0. That's a way to check it when you graph it. And if it does not have reflective symmetry over the y-axis, and it does not have 180-degree rotational symmetry around the origin, then it is neither even nor odd. All right, and that's what I'm going to leave you with on the next slide, guys. Answer the question, are these odd, even, or neither? And I want you to show it algebraically and show it graphically. Okay? You might want to start with the graph, because I think that's going to be a little easier. And then go back and show it algebraically. Prove it after you've got it on the graph. All right, guys, I'll see you in class tomorrow. Have a good day.